I have a hard drive out of an old computer, and I hooked it up to two integrated circuits here that compare the voltages coming off the hard drive motor. And when it compares them, it sends out a signal to the microcontroller, and the microcontroller tests the signals so it can tell if I'm turning clockwise or counterclockwise. So it counts up or down. Each of these are representing one decimal digit in binary. So there's 4 binary bits for each digit. It counts to 0 through 9, and then it adds 1 to the tens digit, 0 through 9. Then when it goes above that, it adds 1 to the hundredths digit here. You can see the signal coming to the microcontroller on the oscilloscope up here from the circuit I built to compare the outputs from the motor. And you can notice it kind of leans to the left. If I turn it counterclockwise, the signals are going this way. If I turn it clockwise, the signals are going this way. And that's enough information for me to use in the program I wrote in the microcontroller to compare the signals and add or subtract 1 from the counter. It will add or subtract about 24 counts per revolution of the hard drive. It's just an old hard drive motor I took out of an old hard drive, out of an old computer. And this circuit is just a counter. This is counting slowly about 4 times a second, and is sending the value that it counts up to over serial communication. So it's only using a couple wires to send the information to the other microcontroller, and this other microcontroller is taking the value and displaying it on these 4 LED lights. So it's just counting, is all it's doing, but it's demonstrating the serial communication between 2 microcontrollers. That's it.
Okay. So what you're doing in this
This
one?
is another program I wrote. Are you ready?
Yeah, I'm ready.
This is another program I wrote in assembly language, and I put this program on this microcontroller here, and this microcontroller is reading a voltage that's varying anywhere between 0 and 5 volts. It's called an analog voltage into the microcontroller, and then it's scaling the value and outputting it using a timer to this servo motor to control the position of the motor. So when I turn it full left, the motor goes full counterclockwise. I turn it full clockwise, and the motor goes full clockwise. And anywhere in between, I can turn it back and forth, and the motor responds depending on where I set the. So this could be any kind of a sensor that has an output of 0 to 5 volts. It could be measuring temperature, pressure, position, or a touch sensor, flex sensor, load cell, anything that has an output of 0 to 5 volts. And then it reads it, and it's controlling, right now it controls the motor. You could control whatever you want with it. So this is just a potentiometer that has a voltage output from 0 to 5 volts on the output going over here to the microcontroller. And then it's reading that analog voltage input and converting it to a decimal number between 0 and 1023. Then in the program I'm scaling that number to be between 0 and 1600, which I'm doing that down here at the bottom of the program. I'm scaling it. Then I'm adding the number from 0 to 1600 to 700, and that produces a result of 700 up to 2300, and that number is put in timer 1 as the number of microseconds long that the pulse is to the motor. So the pulse to the motor is from 700 to 2300 microseconds, and that controls the position of the motor. And that's it.
Okay, thank you, sir.